This is a howitzer, but the men who created it never, ever dreamed that it would one day be fired from the sky. Armed forces have developed aerial weaponry to its maximum potential ever since aviation was first developed. The first airborne bombs were dropped by pilots during World War I. 40-50 bombs could be launched in a single flight during World War II, and by the Vietnam War, aircraft were equipped with anything from napalm to toy guns. However, how one aircraft manufacturer was able to make the howitzer fly, and why howitzer pilots are required to wear night vision goggles, are also important to note. The US Air Force developed its own idea of close air support over the course of the 20th century, establishing doctrines that let ground forces to radio and attack aircraft. These assaults typically used 1 to 2 aircraft that were scrambled from airfields or carriers, and equipped with payloads tailored to the type of target they were called in on, such as armor, people, or structures. Two issues with this kind of ground assault gradually became clear to the US Air Force. While bombs could be guided to strike their target, an aircraft could only make so many passes over the area before running out of ammunition. As a result, the effectiveness of a bombing or strafing run was constrained by its precision and duration. The US military realized that a higher rate of fire was required on all fronts as it proceeded to refine its tactics during the Vietnam War. The US had created the first flying gunship, the AC-47, also known as Puff, the Magic Dragon, by 1965. At first, newly built helicopters armed with door gunners were deployed, but their fuel capacity prohibited the kind of endurance the military wanted. The idea was deceptively straightforward and economical, because it merely called for 3 7.62mm miniguns installed on the left side of the conventional C-47, the Air Force's most prevalent cargo plane at the time. Puff the Magic Dragon became incredibly popular for one key reason. It could linger over the battlefield for up to 3.5 hours, giving the troops on the ground constant support as other targets were called in. Due to its capacity to fly in a circle, it could fire on targets while aiming its left side in their direction, dealing far more sustained damage to the adversary. Although Puff was initially successful, the low wing profile of the C-47 limited the number and configuration of guns that could be fitted to it. With the AC-47's success, the Air Force experimented more with side-mounted weapons and cargo planes, and it started turning the C-130, the most technologically advanced cargo jet the US had at the time, into a gunship similar to the AC-47. The C-130 could fly farther, faster, and longer than the C-47 because of its size, fuel economy, and ability to refuel from the air. But most importantly, it could carry 5 times as much firepower as its forerunner. 4 miniguns and 4 rotary cannons were initially utilized in the AC-130, but within a year of its release, Lockheed modified the aircraft with a surprise package that added 20mm and 40mm cannons. This model, the AC-130A, was given the nickname Spectre since it primarily emerged at night, much like a ghost, since flying at night shields the large, slow cargo plane from anti-aircraft weapons and permits it to loiter without being interfered with by small arms fire. This reputation for nocturnal activity has persisted to the present. Even so, it didn't take long for the US Air Force to realize they needed even greater firepower from the AC-130, and in 1972, the first 105mm howitzer was sent to Vietnam to be mounted to the AC-130 airframe. The most challenging weapon to equip on a plane is a howitzer. This is due to the unique design of howitzers, which are basically a hybrid between mortars and conventional cannons. As you can see, cannons like those on tanks or anti-tank positions are designed to fire forward with little elevation. On the other hand, mortars are designed to fire almost vertically, with only a modest enough slope enable the shell to advance. However, howitzers, particularly those produced in America, are designed to fire at angles between 40 and 90 degrees. How, therefore, did the 2 largest aeroplane manufacturers in the world manage to pull this off? Due to the AC-130's status as a joint venture between Lockheed and Boeing, it had unrestricted resources to have the M102 howitzer fitted specifically to its aircraft. First, they had to address the 2 issues that gas and recoil are present in all firearms. Although a side-mounted howitzer's recoil did push the aircraft 6 feet in the other direction when fired, it had no effect on the airframe's lifting capacity. However, it was exceedingly risky to have a huge piece of equipment moving back and forth when the crew was nearby. In order to address this, Boeing constructed a safety cage made up of several yellow painted bars, which keeps crew members out of the way of the gun's recoil. Second, because of the sealed and pressurized nature of the C-130 cabin's original construction, the crew would be at risk from gas buildup from the gun. Because Boeing chose to reroute the gas via the howitzer's front in this case, the M102s on the AC-130 had a recognizable thick muzzle. Due to the M102's ability to fire a variety of shells depending on the mission, including high explosive rounds for convoy interdiction and flares for nighttime visibility, the gunship's tactical options increased with the inclusion of the howitzer. Boeing had to figure out a mechanism to guarantee the effectiveness of all the weapon systems on board after solving the mounting problems for such a weapon on the aircraft. Naturally, they loaded targeting computers and fire control consoles into the spacious cargo bay. The mission operator pallet, often known as MOP for short, uses a pair of joysticks to zoom in and out and control where the gun is aimed. The crew has been able to engage two different targets that are more than half a mile apart, thanks to advancements in software and sensor arrays over time. This makes it easier for gunners to strike their targets. But how do pilots know where to place the plane's cannons so that they are facing the appropriate way? The pilot establishes an ideal range where all of the gunship's weaponry systems are effective. Once a target has been located, the pilot then performs a maneuver known as a pylon turn, which involves flying in a close, circular pattern around the objective. Despite expensive technology, pilots have discovered a more straightforward solution. They employ the same low-cost holographic sights that infantry and special forces use for their rifles to ensure that the gunners hit their targets. The pilot can alter his turn to just the right angle for the gunners to continue firing by maintaining the holographic sight pointed at the intended target. Pilots of the AC-130 came up with the brilliant idea of learning to fly while wearing night vision goggles. This ability is essential because nighttime missions need the gunships to be totally blacked out in order to avoid giving away their location in the sky. With all of these capabilities, the gunships of the AC-130 lineage have been in continuous service since their inception during the Vietnam War and have developed a reputation among the ground soldiers as their guardian angel. Nevertheless, despite the platform's popularity, it is not without faults. The AC-130 is primarily a transport plane despite its weaponry. It is only deployed when complete air superiority and ground suppression are guaranteed, because its bulk and slow maneuverability make it vulnerable to all sorts of anti-air fire. But as technology advances, pure air superiority seems less and less feasible. Even if air superiority is gained today, a big freight jet in the skies is still an easy target due to the advancements made in drones and missiles. Cheap drones may readily deliver an air-to-air missile against an AC-130 due to their rapid speeds and low radar signatures. Modern standoff missiles can be fired at tremendous rates that may be too fast for the crew to even respond, making the skies even deadlier for the gunship. Is it still worth the cost and risk? Even though the Air Force has invested in a number of laser technology and sensors to modernize the gunship even more and increase its survivability. Presently, yes, considering that the US uses the AC-130 in novel anti-terrorism activities. But will the AC-130 vanish if it ever encounters more sophisticated foes?